Alright, this is for geometry, section 5.2 continued. And we're basically going to talk about two things today: the circumcenter of a triangle and the incenter of a triangle, and the difference between those two things. First, I want to give you a little bit of review of what we've done so far. Okay, so far in chapter 5, this is where we're at. We're in the first box. So far in chapter 5, we've did perpendiculars and bisectors from section 5.1. We have 4 theorems that we spoke about, and all of those should be in your tool kit. If they're not, make sure that you download my copy and put it in there. Theorem 5.1, 5.2, 5.3, and 5.4. They're all about perpendicular bisectors, the perpendicular bisector theorem, the converse of that perpendicular bisector theorem, the angle bisector theorem, and then the converse to that. So that's all from section 5.1, and those should be in your toolkit. From 5.2, we spoke about bisectors of a triangle, and then the big idea from 5.2 so far is this thing called the circumcenter. Now, the circumcenter is a point that is equidistant from the vertices, or from the edges of a triangle. Not the edges, excuse me, from the points of a triangle. So this is vertex A, this is vertex B, this is vertex C. So the point that is equidistant from all of those is called the circumcenter, and the way that you get it is you construct it by using perpendicular bisectors. So you have to know how to do that. Then we spoke about theorem 5.5, which basically says what I just said, so make sure that's in your toolkit as well, theorem 5.5. Then we have some new stuff, right? Something called the incenter of a triangle. The incenter of a triangle is the point that's equidistant from the sides of a triangle. So the question was then, what is the side of a triangle? And we define the side of a triangle as the point that is closest to that side. So as an example over here, turns out that the distance that's closest to the side of the triangle is perpendicular to that side and that point. So as you can see, these 3 blue distances here are the shortest distances from that point to the side of that triangle at right angles. That's the side of the triangle. All of those are equal. When you find that particular point, that's called the incenter. And the way that we construct that is by angle bisectors. Okay, so the incenter is the point that's equidistant from the sides. The circumcenter is the point that's equidistant from the vertices. So those are the 2 different things that we get in chapter 5 so far. The box number 3 here is a construction, which I'll post a link on to how to construct the incenter of a triangle. So we go through that, and we had another set of notes that I handed out in class that we practiced doing some constructions on. So make sure you get that from me or from one of your friends in the class. Okay, and then the 4th example was we copied the diagram here of a triangle, and we practiced constructing the incenter. And then the cool thing about constructing the incenter is that when you do construct it, you can fit a circle inside that triangle. That's the biggest circle you can fit inside of any triangle, and you should be able to draw a circle inside that triangle. Oh, go away. And we get that from the fact that all of these are the same length. So if all of those are the same length, we are inscribing a triangle basically by using the incenter. So that was a pretty fun activity that we did in class. Okay. So so far for the lesson in chapter 5, a little bit of review. 5.1 is all about perpendiculars and bisectors. We have 4 theorems in our toolkit. 5.2 was the idea of a circumcenter. It is the point that's equidistant from the vertices. We construct it by perpendicular bisectors. I'll post a video to that so you can see it. The incenter of a triangle, point equidistant from the sides of a triangle. And of course, the sides are perpendicular to the point there, from the shortest distance to the edge of that triangle. And then we construct it by perpendicular bisectors. Very important. Then we did a construction, which I'll post. Look for the link. And then we did another construction in class. And then finally, I had 2 follow-up questions that I posed to the class as part of their homework. So answer the following. So number 1, what is true about the perpendicular bisector of any triangle? Write at least 2 sentences. And then number 2, what is true about any angle bisector of any triangle? Write at least 2 sentences. So go ahead and fill those out, and we'll talk about those on Friday. All right, there you go.